We have stretches of functions. Blinking, yeah. A stretch is a transformation that changes the size and the shape of the graph. The original and the new graph are not congruent. They don't look the same. There are two types of stretches. Vertical, which we did last year. A vertical stretch is when it affects the y, so on the outside, right? So vertical translations are outside, right? Not in the brackets. Vertical stretches are outside. Horizontal translations are with the x. Horizontal stretches are with the x. So horizontal stays the same, vertical stays the same, which is nice. Okay? So if it's in the bracket with the x, it's a horizontal stretch or a horizontal translation. Okay? So vertical stretches are this form. Y equals a f of x. Okay? So you'd say vertical stretch by a factor of, BAFO means by a factor of. It's just my short form, so I don't have to write that every single time. Vertical stretch by a factor of a about the x-axis. So when it's with the y, it's a reflection in the x-axis. When it's with the y, it's a stretch about the x-axis. Okay? And we do as we say. So just like with mapping, we've always done what we said, right? So if it horizontally translated 7 right, we moved it, added 7, right? If it was a reflection of the y-axis, we'd put a negative x. We do what we say. So if it's a vertical stretch by a factor of a, we're going to multiply the y by a, just like we multiplied the y by -1 when it was a reflection. Once again, the points on the x-axis are invariant. Why would the points on the x-axis not change? What's the only thing changing in this? The x is staying the same, but my y's are being multiplied by something, correct? On the x-axis, what are your y's? On the x-axis, what does y equal? 0. When you multiply anything by 0, what happens? Stays 0, right? So that's why the x-axis is invariant, because your y values are 0. And when you multiply by 0, it doesn't change, right? And the x's don't change. If a has a negative sign in front of it, that's a reflection, not a stretch. So you never ever say vertical stretch by a factor of -3. Is that negative stretching it at all? No, the negative is reflecting it. Okay? So your stretches always are positive values. So vertical stretch by a factor of a, vertical stretch by a factor of 3, 7, 9. If there's a negative in front, it's not a stretch, it's a reflection. Okay? So your stretches are always negative. I mean, are always positive, not negative. The opposite of what I said. Okay. So describe the transformations that occurred here. This is going to be vertical because it's not with the x, correct? Anything not with the x is vertical or a reflection in the y, correct? Anything with the x is horizontal or a reflection in the y. Reflection in the x, reflection in the y. Okay, so this one here, we have a -4. We always go in the order stretch, reflect, translate. So my stretch, this is a vertical stretch because it's not with the x. A vertical stretch by a factor of what? 4. Can it ever be negative? No. If it's negative, it's a reflection. It's not a stretch. Vertical stretch by a factor of 4 about the what? The x-axis. It's always about the axis that it is not affecting, right? So if it's a vertical, it's affecting all your y's, correct? In order to affect your y's, it's going to be about the x because it's going to flop up or down, or it's going to stretch it about the x. Do I have a horizontal stretch? No, we haven't even discussed horizontal, and it would have to be with the x, okay? We have a negative in front, so we have a reflection in the what axis? In the x. So always about the y when it's with the x, and when it's with the y, it's about the x, right? It's the opposite axis. Any translations? Stays that way. Okay. We're moving a graph. When we move a graph, what do we use? Mapping. Okay. They want us to sketch y equals 2f of x. Mapping is easier if you actually have the words because you do what you say, correct? So let's write out what we're doing here. Stretch, reflect, translate. Do we have any stretches? Yes. It's in front. So we have a what stretch? Vertical or horizontal? Vertical because it's not with the x. Vertical stretch by a factor of 2 about the what? X-axis. Reflection, translation, anything else? No. Is anything with the x in the bracket? No. So my points are x, y. To do my mapping, my x is going to stay x because in the bracket there's nothing but an x, right? So nothing changed on the x. Vertical stretches and reflections you multiply. The only thing you add and subtract are translations. Okay? So we have a vertical stretch by 2. So we get 2y. So this one's an easy one to do. Your x's stay the same. Your y's get multiplied by 2. So x is -2. Y is 0 times 2, which is 0. It's invariant. Why is it invariant? Because it's on the x-axis, right? So that one's going to stay the same. -1 stays -1 for x, and my y is 2. 2 times 2 is 4. So -1 and 4. And then I connect them right away. So I don't have random dots everywhere guessing where I'm connecting them. Next one is 0 and 5. 0 stays 0. 5 times 2 is 10. Why didn't that one remain invariant? It's on the y-axis, right? It's a y-intercept, not an x-intercept. My y wasn't 0. And then 4, 0 stays 4, 0. Now, some people will say, how is that a stretch about the x-axis? Why does this not look like I stretched it about the x-axis as much? Pardon? Looks like it's moving up. I have no what points? I have no negatives right now. If I had negatives, the negatives would get pulled down, and the positive y's would get pulled up, and what would I be stretching about? Which axis? The x, right? It would be more noticeable that it was about the x, because I'd be pulling up and pulling down. But in this way, I'm only pulling it up, so it doesn't seem like it's stretching it as much about the x-axis, but it is. Okay? If you had negative y's and positive y's, it would pull them this way, and I'm stretching about the x-axis. That's why the vertical is about the x. Okay? So this is replacement notation. Graph y equals x squared. So we have to graph the y equals x squared. The y equals x squared graph is 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, 3, 9, etc. Now, how could I get that? I could plug 0 into x squared. 0 squared is 0, so I get 0, 0. I could plug 1 into x squared, so I get 1 squared is 1. -1 squared is 1, and get the graph. Or I could go y equals x squared into my calculator and go second graph and pull values off the table of values, right? Because that gives me points off the graph. So I could go y equals x squared into my calculator and go second graph and look at my table of values, my points, and plot those. But you might have to check for the min and the max, right? Because sometimes if the min or max is a decimal, it's not going to show up on your table of values. Okay. Then they want us to replace y with 3y. So I'm taking the y, I'm hucking it out, and I'm replacing it with 3y. So y equals x squared. I'm taking this y, I'm getting rid of it, and I'm going to replace it with 3y. Replacement notation is actually a really good definition for the word because you're replacing every single time. Okay? However, it's still with the y, and what I told you is always get y by itself, and then it's a lot easier, correct? So I'm going to divide by 3, both sides. Now, if I actually had like a plus 6 at the back, I'd have to divide that by 3 as well, would I not? So you have to remember to divide the whole side by it. I just don't have a plus 6, so I don't have to. I'm going to get y equals, division of 3 is the same as writing a third in front. X squared. Is it with the x currently? What's with the x right now? Squared. Currently, it's not with the x. It's in front, is it not? The vertical stretch, I just divided it over. I'll show you how you can put it with the x, but right now it's not with the x. So right now I have a vertical stretch by a factor of a third about the, what axis? When we get to horizontal, we're going to come back here and I'm going to show you how it could be a horizontal stretch as well. It really only works with squared, so with like quadratics. We'll come back to this one once we do horizontal. So we're going to do mapping. Our xy is going to become x and what? Do as you say. Vertical stretch by a factor of a third. 1/3 y. So whenever you go to do mapping, if you write out your stuff first, your mapping is whatever those numbers are. You literally just do what you say. Because you're saying you're stretching it by a third, so you're going to take every point and you're going to multiply it by a third because you're stretching it by a third. So you do as you say. Okay? All right. So 0, 0 is going to remain 0, 0. 1, 1 is going to become 1 and 1/3 times 1. So 1 1/3. It's like 0.333. It's out here. Negative 1 and 1 is going to become negative 1 and 1/3 times 1. So negative 1 1/3. Two and 4 is going to become 2 and 1/3 times 4. 1/3 times 4, it's 4/3. 4/3 is 1.33333333333333. Keeps going. And then it's symmetrical, so this is going to be 1.333. And that's your new graph, right? Example 4. Y equals square root x. Plug it into your calculator. Y equals square root x. Some people say, what mode do I have to be in? It doesn't matter what mode you're in. The only time mode matters, so radian and degrees, is if you press the sine, cos, tan button or the second sine, second cos, second tan button. So if you're not pressing these 3 buttons here or the second version of those, the mode does not matter at all on your test. You could have it in radian or degree and it ain't going to change it. Okay, so it's only these 3 buttons that it matters. So we're going to go square root x, and then you're going to go second graph. And it says error with a lot of them, doesn't it? Go up if you don't see error. Why would there be errors? What that table of values is doing is what? Why would there be errors? Nope. Close. Close. Yeah. Yes, so you're very close. You can't square root a negative. The issue is the negative. Because when we're doing that calculator, when it's doing the table of values, what it's doing is it's plugging those values in for x and solving for y, correct? So if I plug -2 in for x, square root of -2, does not exist. So that's why it's erroring. -1, square root of -1 does not exist. 0, square root of 0 is 0. So that's why it starts at 0. Okay? Then I plug a 1 in. Square root of 1, 1. The next one I'm going to go to is 4 for x. Why wouldn't I pick the other ones? Well, you can pick the other ones. The catch is they're decimal wise, so they're harder to graph and be accurate with, right? But if I go to 4, 4 is a perfect square. So the square root of 4 is 2. The next one I'm going to go to is the next perfect square, which is 9. So if I go to the square root of 9, it's going to be 3. So I'm going to do 9 and 3. Pretend that went through there, which it didn't look like it. All right. Now we're going to draw the new graph. Giver. Replace y with 1/2 y and see what you get. Maybe do it in pencil. So this one is a replacement. So you're going to get 1/2 y equals square root x. When you move it over, you're going to multiply by 2. So you're going to get y equals 2 root x. So it's a vertical stretch by a factor of what? 2. It's not horizontal because it's not under the square root sign with the x. Remember, the square root sign is just like having brackets, okay? Anything under that square root sign is affecting the x. Anything not under that square root sign is outside of the x, and it affects the y's. So we have vertical stretch by a factor of 2 about the x-axis. It never changes. That's why I always move it over. I always move it over away from the y, so it's always just what it is. What number it is, you say it is, you write it down, it's vertical stretch. Okay? Doesn't change. So my x's are going to stay the same, and my y's are going to be multiplied by 2. So 0, 0 is going to remain 0 and 0, because 2 times 0 is 0. 1 and 1 is going to become 1, and 2 times 1, so 1 and 2. Four and 2 is going to become 4 and 4, right? Because 2 times 2 is 4. 9 and 3 is going to become 9 and 6. Now, for your own benefit, because you're probably drawing in the same exact color, also because you should do this as a good math student, you should label these. So this one is y equals square root x, and this one is y equals 2 root x. First off, so that when you go back, you know which one is which. And second off, that's what you're supposed to do. Label your equations. So when you have more than one, you label it so you know which one is which. And so I know which one is which when I'm marking yours. Okay, horizontal stretches are a little bit tricky. So everything so far that deals with the y, we just take what it is, right? So if it's a vertical stretch by 2, there's a 2 there. If it's a reflection in the x-axis, there's a negative there. If it's vertical translation up, there's up 1. Let's say there's a +1 at the back. We agree? Horizontal so far, the only thing that we've taken as is the reflection, right? If there's a negative in front, it's a reflection in the y. That doesn't change. Do you agree? But the horizontal translations we did backwards, didn't we? So if it was x minus 3, we actually went 3 to the right. We agree? If it was x plus 4, we went 4 to the left. It was complete opposite. Stretch is the same deal. It's going to be the reciprocal. So if you have a 2 in front, you're actually going to multiply by the reciprocal. Reciprocal means flipped version. So 2 is actually over 1, is it not? Any number can be over 1. So if it was a 2 in front of the x, you're actually going to multiply by a half. If it's a quarter in front of the x, you're going to multiply by 4. So your horizontal stretches always flip. Always. It's not like, do they sometimes flip? No, they always flip. Just like your horizontal translations are always the opposite, your horizontal stretches are always the flipped. Okay? Doesn't change. It's the good thing about this. It's consistent. It does not change. Whatever you do every single time. Okay? So we'll look at that in a second. Let's look here for an actual example before we look at these, which seems confusing. Okay, so with our x, we have a number in front, do we not? What if I had this? What would I have to do first? Take out the 5, or else my horizontal translation is going to be wrong. You're going to tell me it's 5 to the left when actually it's 1. It's still in the bracket with the x, correct? So some people will say, well, it's not in the bracket with the x. It is. These are the brackets with the x. This has to have a 1 in front if you want the horizontal translation to be correct. Okay? This has absolutely nothing to do with that question I just showed you, just in case you saw it. So if you're wondering where I got this random 5 from, I made the question up. It has nothing to do with that example 1. Nothing. Okay? You don't just randomly add 5s to it and make a new equation. It's not what you do. I just was showing you that if there's a horizontal stretch and it's not taken out, you have to. Okay? All right. So it's with the x. So we have stretch, reflect, translate. There's no reflections. There's no translations. There's no vertical stretch because there's no number in front of the f. We agree? The only thing we have here is a horizontal stretch. Because it's with the x, it's horizontal. It's a horizontal translation or a horizontal stretch or a reflection in the y. You never say a horizontal reflection. There's no such thing. But you do say horizontal stretch. So horizontal stretch by a factor of BAFO. This is horizontal stretch. By a factor of. It's a 5 beside the x. So we actually say by a factor of what? 1/5. About the y-axis, just like the reflection would have been about the y-axis. Now mapping, you do as you say. What did we say? What number did we say? 1/5. So what are we going to multiply by? 1/5. We just do as we say. Okay? So if I wanted you to do mapping, which I didn't make you do here, but say we did mapping, you're going to have x, y, and it's going to become 1/5 x and y. So you do as you say. So if ever you want to do mapping, it's easier to write out whatever the heck the transformations are and then just do the mapping from there. Often people find it a bit easier. Okay. So we're changing a graph. If we're changing a graph, we have a horizontal stretch by a factor of what in this instance? 1/2, because it would be 2/1, but the stretch is actually the reciprocal of that. So a half. About the what axis? So we do as we say. Is there anything with the word vertical in here? Is there anything not in the brackets? Any extra numbers? No. So our y is going to stay y. But our x is going to be multiplied by what? Half. Remember, you always multiply except for translations. So if you're moving it up, down, left, or right, those you add or subtract. Everything else, stretches and reflections, you multiply. And that's why we do it in the order SRT. We do it in the order SRT because SRT follows BEDMAS rules. BEDMAS rules are brackets, multiplication, brackets, exponents, which we don't have, multiplication, division, addition, subtraction, right? We are multiplying when we're stretching and reflecting, and we're adding and subtracting when we're translating, right? So that's why we have to go SRT, because we have to go in BEDMAS order. Stretch, reflect, you multiply by. Translations, you add or subtract. Okay? It has to go in that order, or else you're not doing BEDMAS and you'll get it wrong. So this point, -2 and 0, is going to become -1 and 0. This point, -1 and 2, is going to become -1/2 and 2. this is 0 and 5 is going to be 0 and 5. Remains invariant because my x is 0. When I multiply anything by 0, it stays 0. And then this one is going to become 2, 0. What axis am I stretching it about? Y. We're going to look at this one here. So it says replace x with 2x, but we're going to graph that x squared first. So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Okay? It says to replace the x with 2x. So we have y equals x squared. We're going to take this x, we're going to huck it behind our shoulder, and we're going to replace it with 2x squared. Right? Is it with the x right now? Is it in the bracket with the x? Yes. So what kind of stretch is it? Horizontal stretch by a factor of what? About the, that's the only thing that's happening right now, correct? So my points, x, y, are going to become what? 1/2 x and y. So if I go to graph that, 0, 0. 1/2 x, same y, so it's going to go here. 1/2 x, same y, going to go here. 1/2 x, same y. 1/2 of x, same y. So I get this red graph, we agree? Now I told you we're going to look back at this type of question when we deal with it in horizontal, and it's a quadratic, correct? This only works with quadratics. It also can work with radicals as well, but we'll deal with that more so when we're at radicals. I can expand that, can I not? Can I expand 2x squared? So your answer is going to be horizontal stretch by a factor of 1/2 about the y-axis, which is correct, but that's not a multiple choice answer. So you're like, oh crap, what is the answer? Well, you can expand this. So we do replace it like they said, but now we could expand it. So 2 squared x squared. So it would be 4x squared. Would it not? Is the 4 now in the bracket? No. Is it still a horizontal stretch? No, it's not with the x. What is it? It's a vertical stretch by a factor of what? 4. The only one that we flip is horizontal, right? About the x-axis. And some people will say, well, that's great, but I'm not going to get the same mapping. You won't get the exact same points, but you will get the same graph. Let's see. So we have xy. It's going to become x and 4y, because we do as we say. So let's keep our x's and multiply our y's by 4. So we have 0, 0. Stays the same, right? Let's plug in 1, 1. It's going to become 1 and 4 times 1. So it's going to be 1 and 4. Now some of people will say, well, there wasn't 1 and 4 on the other one. Well, there actually is. 1, 2. This is going to become, did we get these two little spots down here? No, but you could have. You would just have to use a different x value. But it indirectly gets me the exact same graph, does it not? It works with quadratics because you can actually square it and bring it back out. If there's a little f in there, had it been like this, could I do anything to get that to be in front of the f? No. There's an f. There's no way I can get that number to just plop itself in front of the f. It's never going to happen. It'll always stay there. It's only in unique instances like a quadratic that this can happen. Because you can actually do algebra to it to change it into a vertical stretch. If you have an f in it, there's nothing you're doing to get that to be a vertical. Nothing. All right? Let's go to example 6. We have all the transformations now. So the very first thing I do when I'm asked to describe any transformations is I see, is there a 1 in front of the x? If there's not a 1 in front of the x, I have to GCF it before I can say any transformations. Okay? This x is in its own bracket, technically, because when the 2, if this 2 was with the x, it would be in the bracket. Is it in the bracket? No, so it's not with the bracket. So this x has a 1 in front of it, does it not? Yeah, so I don't have to do anything else. I can just start listing my transformations. Is there anything with the x at all? No. So there's going to be no horizontal stretch. There's going to be no reflection in the y. There's going to be no horizontal translations. Nothing. X is x. Nothing happened to it. Okay? So all of this is all affecting the y. So my stretch, it's in front of the x, correct? It's not with it. So I have a vertical stretch by a factor of what? 2. Can it ever be negative? No. About the what? The x-axis. Do I have a horizontal stretch at all? No, there's nothing with the x. So now I move to my reflections. Is there any negatives being multiplied in front? Is there a negative in front of the x? No. Is there a negative here? Yes. So I have a reflection in the what? X-axis. Remember, it's always the opposite axis of what you're looking at. So if it's with the x, it's about the y-axis. If it's not with the x, it's about the x-axis. Translations. I have a vertical translation 3 what? What's my problem with B? You have to GCF out of it because there's not a 1 in front of that x, is there? So I have to take out a negative 2. I take out a negative 2, and I'm left with x. That's 4 divided by negative 2. So they're going to have 4 to the left as an answer. Is 4 to the left correct? No. It's the most painful answer on there. When you guys pick it, it makes me cry a little inside. 4 to the left will be there. It's not correct. You have to remember to take out the GCF. It will be there. Okay? So, is there anything not with the x? If it's with the x, it's in brackets squared. Is everything with the x? Yes. There's nothing not with the x. There's no vertical stretches. There's no reflection in the x-axis. There's no vertical translations. It's all horizontal. So S, we have a horizontal stretch by a factor of what? You have to remember this every time. 1/2. It flips every time. Some people are like, well, when doesn't it flip? It never. It always flips. It's a good thing about it. You should be happy about that. It just always flips. Okay? Half, not negative a half. Half about the y-axis. Do we have a reflection? Yes, we have a negative in front of that too. So we have a reflection in the what? The y-axis. Do we have any translation? Yes, we have a horizontal translation to right. So my mapping, my xy, is going to become horizontal stretch by a factor of a half, means I multiply my x's by a half. There's a reflection in the y-axis, which means I multiply my x's by actually negative a half. And then to right, I add 2. So I'm going to get negative a half x plus 2. What happens to my y's? Okay. What happens if they give us the words and we have to come up with the equation? So we have a horizontal stretch by a factor of 6. This is the word. They want me to write the new equation. So what's it affecting, my x or my y? X because it says y-axis, and because it says horizontal. So we're going to have y equals f. They're going to have 2 answers on your diploma. 6x, 1/6x. Actually, they're going to have 4. Y equals 1/6 f of x, y equals 6 f of x, y equals f of 1/6 x, y equals f of 6x. They're going to have every stretch possible because, well, why wouldn't they? And they have every single oopsie. When we put these back in vertical, when we put vertical back in, we just put the number back in, correct? But when we put horizontal back in, what do we have to remember to do? Reciprocate it, because we reciprocated it to take it out. So we're not going to put in 6x, we're going to put in 1/6x. Always flips coming out, always flips going back in. Okay? Only horizontal though. Vertical, you put in. We have a vertical stretch by a factor of 1/5. Just like the reflection though, it has to apply to the whole equation. So we're going to have y equals 1/5 f of x, which is great. But what if I gave you this equation instead? Say the original was y equals f of x plus 7. Remember, with the reflection in the x-axis, you would have to apply the negative to the front and to the plus 7, right? Same thing with stretches. So if this was my original, I'd have to go y equals 1/5, and I apply it to the front. But that means I apply to the whole thing, correct? So I would actually get 1/5 f of x plus 7/5. So remember, your vertical stretch and your vertical translation, or sorry, your vertical stretch and your reflection in the x have to apply to the whole equation. So if there's a vertical translation, it affects it. Everyone forgets to make it go to that. Okay? Let's look at D. Horizontal stretch by a half. So I have y equals f of x. It's going to become y equals f of what? Horizontal stretch by a half. So it goes to the x, but it does what? Flips to go back in. It's reciprocal to go back in. So we get 2x. And a vertical stretch by a quarter. Quarter in front. Now, why didn't I put it in brackets and apply it to the whole thing? I did apply it to the whole thing. You only need brackets if what did I need back here in order to have brackets so that I made sure I put it to the whole thing. If I had a vertical translation, like a plus 7 at the back, I would have to make that quarter go to the plus 7 as well. Goodness. I just want the homework. Tomorrow, all we're doing is I'm giving you equations with everything, or I'm making you make equations with everything, or I'm making you move graphs with everything. So now instead of having horizontal translations by themselves and vertical and stretches by themselves and reflections by themselves, you're going to have everything together and you have to answer it. So all of the stretches, the reflections, the translations, just like what we were just doing before that, where I gave you all of them. We had to say SRT. That's what we're going to do tomorrow. Whole bunch of that. And then inverses the next day.